Okay, so the answer to this first free response question, if you look at this, we know this is an endothermic reaction because the temperature is dropping. In other words, because the temperature measures the surroundings, endothermic reactions pull heat from the surroundings into the system. So we know for this delta H has to be positive. It's not like a bond energy. We know that breaking bonds, that's what happens in the reactants. We know that's an endothermic process, and we know that forming bonds, that's what happens in the products. That's an exothermic process. So in this case, because the overall reaction is endothermic, the energy required to break the bonds must be greater than the energy you get when you make them. Makes sense. If delta H equals broken minus formed, and broken is greater than formed, you're going to get a positive number. Therefore, the bond energy of the reactants is greater than that of the products. In this next problem, you simply draw out the Lewis structures. What makes this a little tricky is the Lewis structure for ICl. But in the table, they gave you the ICl bond. So you know that's there, and logic would have it that in ICl, there's 3 of those. So you do 1 of the 150s plus 3 times the 240s. That gives you the number for broken, and you subtract that by 6 times the 210. 3 of them are in the ICl, and that's occurring twice. You're going to end up with B, negative 390.